Hello. Uh, Today we'll be discussing about uh, sphere and uh, and we'll also talk about how plane collide with a sphere, whether there is collision, there is no collision. So first we'll try to calculate whether a plane collide with a sphere. So we have here an example. Given sphere A having a center 1 with center coordinate 1, 3 and 50, and the radius of the sphere is 50, and we also have a plane P having coordinate 1, 0, 0, 1, 0, and with uh, D to be minus 2.0. So we have the formula here. D is equals to AS naught plus BY naught plus CZ naught plus D divided by A square plus B square plus C square. So where this D is the distance of the intersected sphere and plane. So normally for a plane to collide with a sphere, the radius arrow of the sphere must be greater than the distance d of the intersected plane and the sphere. So, but when d is equal to the radius arrow of the sphere, it shows that there is tangency, that is, the plane only touched the sphere, it did not intersect. But when arrow is less than d, then there is no intersection. But in this problem, we try to substitute the various values that we have here into this equation. So if you see now that from the above formula we have s naught, y naught, z naught. This s naught, y naught, z naught, they are the center coordinate of the sphere. That's 1, 3 and 50. And we also have a, b and c. They are the coordinates of the plane. So it's shown now that if we substitute the various values of 0, 1, 0 in place of a, b and c, and if we substitute the value of 1, 3 minus 50 in place of a naught, y naught and c and z naught, and the value for d is minus 2.0, which is this, then we will arrive by this answer. That is x naught is 1, y naught is 3, z naught is minus 50, and a naught is 0, b is 1, which is the coordinate of the plane, and c is also 0, and the d is minus 2. So if we evaluate, we arrive by d is equals to 1. So if you look carefully, d is less than arrow, because arrow is having a value of 5 and d is 1. Then there is no collision. That is clear. There is no collision. The second of the problem is we will try to calculate whether two spheres collide. So for two spheres to collide, there is a condition here. For two spheres to collide, actually this is modulus. So I have to correct this. Is for two spheres to collide, for there to be an intersection between two spheres, then it shows that r0 plus r1 must be greater than d. And okay, this is a minus. This is actually a minus sign, and that and r0 minus r1, the modulus of r0 minus r1 must be less than d. These are the conditions that exist for us to know that there is intersection between two spheres. So given two spheres A and face B. And we have this center coordinate for the sphere and the radius of the sphere, and for B we have this center coordinates and the radius of the sphere is this. Then the equation of the sphere for A is this, and the equation of the sphere for B is this. So the center coordinate for A is x0, y0, z0, and the center coordinate for B is x0, y0, z0, and the radius is r0 for A and r1 for B. So the distance between the sphere therefore is equal to x0 minus x1, that is the x1 of sphere B minus x0 of sphere A, plus the y1 of sphere B minus the y0 of sphere A, plus the z1 of sphere B minus the z0 of sphere A. So you have to square them, and the sum then the square root. So if you evaluate that answer, you will arrive with D to be 10.72 approximately. But the sum of the radii of the two spheres, if we sum their radii, that is 5.0 plus 2.0, we will arrive by 7.0. So you see now that the sum, which is 7.0, is lesser than, actually 7. The sum 7 is lesser than the distance between the intersected sphere. So therefore there is no collision. So that's that. So that's how we can know when a sphere collide with there is collision between two spheres, or when there is no collision between two spheres. Thank you very much and have a great day.